Hey Titans, it's Mr. Spilker here. Today we are going to begin the final exam review. Today's final exam review is going to focus on Chapter 8 and Chapter 9. So go ahead and get your notes out. We're going to go over some examples and some key points from Chapter 8 and the beginning of Chapter 9. And these key points are going to be items that will be on the final exam. So it's going to be important to add these into your final exam notes for today's lesson. Alright, let's jump right into the reminders that we need from Chapter 8. In Chapter 8, you need to remember the laws of exponents. So here are a few quick reminders. The first law, the product property. The product property says that if you are taking two powers and multiplying them, that you add the exponents. So an example of the product property would be x squared, see if my stylus will let me write on here, x squared times x to the 7th equals x to the 9th. I know you're multiplying, but the product property says that when you're multiplying powers, you actually add the exponents. The second property was a power of a power property. And that property said that if you have a power outside a set of parentheses, that you go ahead and multiply your exponents. So x squared times x to the 7th, or excuse me, x squared to the 7th power would be 2 times 7, which is x to the 14th. That's the power of a power property. When you have double powers, you multiply them. The quotient property, obviously quotient division. So let's say we had x to the 8th divided by x squared. X to the 8th divided by x squared, the quotient property tells us that when we are dividing with powers, we subtract our exponents. So 8 minus 2 is 6. So x to the 6th power. That's a reminder of the quotient property. The next property we have here is the negative exponent property. I'm going to go ahead and clear these first three properties so we have a little bit of room to work here. If we clear those drawings off, we can now get to the negative exponent property. The negative exponent property, x to the negative 8th power. Remember, we cannot have negative exponents. So what do we do with negative exponents? We move them down to the basement, and they can change to be positive. So x to the negative 8th is the same as 1 over x to the 8th. We also have the zero exponent property. Anything to the 0 power is equal to 1. Anything to the 0 power is equal to 1. So just remember that zero exponent property. And then the last one we have is negative 1 raised to a power. Remember we talked about in Chapter 8 that if negative 1 is raised to an even power, it always equals positive 1. If negative 1 is raised to an odd power, then it's always equal to negative 1. Those are the important properties from Chapter 8. Now let's put those properties into action by going over a few additional examples. So make sure you have everything down from this slide that you need. Alright, Chapter 8 examples. These are good to have in your notes. These are in a similar, I would say, difficulty level to what you would see on the final exam. 8a to the 4th times 9b to the 3rd. So we're going to go ahead and apply our properties here with your coefficients, 8 and 9. You multiply those two. 8 times 9 is 72. And then with our exponents, we have a to the 4th times b to the 3rd. Now a to the 4th times b to the 3rd, we cannot combine that to be ab to the 7th. It would just simply be a to the 4th, b to the 3rd. Now, if this was a situation in which we had a to the 4th and a to the 3rd, then we'd multiply and we'd have a to the 7th. But since the two variables are different, we just leave it as a to the 4th, b to the 3rd. The next example, we have 3b squared times negative b to the 5th power. So here we're going to go ahead and take that power on the outside of the parentheses and square everything. So 3 squared is 9, and b squared is b to the 4th power. We're then going to multiply that by the second set of parentheses. Now the number out front is a negative 1. So negative 1 to the 5th power would just simply still be negative 1. And then b to the 1st to the 5th power would be b to the 5th. Now we can multiply these two. 9 times negative 1 is negative 9. And b to the 4th times b to the 5th comes out to be b to to the 9th power. Our third example here from chapter 8 gives us 5 to the 5th divided by 5 to the 7th. 5 to the 5th divided by 5 to the 7th. Whenever we're dividing, we subtract our exponents. So I'm going to take 5 minus 7 to get 5 to the negative 2nd power. Now remember, we cannot have negative exponents. So we got to take that 5 to the negative 2nd power, and we got to move it down to the basement. Put it in the basement. In other words, move it to the denominator. And your final answer is 1 over 5 squared, which would be the same as 1 over 25. Alright, 2 more examples here with chapter 8, and then we'll get a couple quick things out of the way with chapter 9 here today in our final review. Keep in mind this video can be paused at any time if needed. You can rewind. We did it on YouTube, so you have those options. So fast forward, rewind, do whatever you need to do as needed. And then this video is also available on the Blogspot. So if we go too fast in class, go back to this video, which is available on TitanAlgebra.com, and use it as needed. So the fourth example here, we're going to go ahead. We have 2 outside the parentheses, so everything has to be squared. Everything on the top, everything on the bottom. So that's going to make the top become 4a to the 8th power. We need the power of power, you multiply. And then on the bottom, we're going to have 3 squared, which is 9, and a squared squared, which would be a to the 4th. Okay. Now we can divide this because 8, or a to the 8th power divided by a to the 4th power, we have like bases, so we can subtract those exponents, and 8 minus 4 is 4. So we have 4a to the 4th over 9. Our last example is a pretty easy one. As you can see, we have 8x cubed y to the 12th raised to the 0 power. Anything to the 0 power always equals, guess what? 1. Pretty simple there. Anything to the 0 power equals 1. So that one we don't even need to worry about, well, hey, we got to take the 0 and distribute it and do all that stuff. We don't. Anything to the 0 power equals 1. So that whole set of parentheses raised to 0 power is just going to equal plain old 1. Alright, we're going to wrap up our review here today with a few examples from Chapter 9. In Chapter 9, we're not going to go over the whole chapter right here in today's review. We're just going to focus on the ability to add, subtract, and multiply polynomials. This should be pretty familiar to you because really all it is combining like terms with addition and subtraction. So let's jump into the addition example. We have 3x squared plus 4x minus 9 plus negative 2x squared minus 9x plus 4. So all we're going to do here is simply combine like terms. 3x squared and negative 2x squared makes 1x squared. 4x and negative 9x, remember it takes the sign in front of it over there on the second set of parentheses. 4 and negative 9 make negative 5x. And then we have negative 9 and positive 4. And negative 9, let's go back to that here, negative 9 and positive 4 make a negative 5. So we have x squared minus 5x minus 5. Alright, example 2 from chapter 9. We have x squared minus 5x minus 9 minus x squared plus 7x minus 2. So to solve one like this, we would go ahead and we see that subtraction. Subtraction, we don't like to do it. We change it to addition, and then everything behind it becomes its opposite. So in that second set of parentheses, x squared had to become negative x squared. 7x had to become negative 7x, and minus 2 had to become plus 2. Once you do that, you can now combine like terms. X squared and negative x squared make 0x squared, so that's nothing. Negative 5x and negative 7x make negative 12x, and then negative 9 and positive 2 make negative 7. So that would leave us with negative 12x minus 7. So there's an example of adding polynomials and subtracting polynomials, which is 2 key skills at the beginning of chapter 9. Alright, the final 2 examples of the day today involve multiplication. The first example is 3x times x plus 8, so if you go ahead and add that one into your notes. On that one, hopefully you're thinking to yourself, oh, this one's easy. All we would do is distribute. 3x times x is 3x squared, and 3x times 8 is 24x. Now we cannot go any further. We can't combine those two because they're not like terms. So our final answer is 3x squared plus 24x. So all we have to do there is distribute. On the second example, we have a binomial times a binomial. Hopefully you remember that when we do a binomial times a binomial, we must use the FOIL method. Alright, so on this example, you're just going to go ahead and use the FOIL method, and when you use the FOIL method, you would go ahead and take x times 2x to get 2x squared. You do the first terms. Then you go last, you take x times negative 8 to get negative 8x. Then you go inside 5 times 2x to get 10x. And then you do last 5 times negative 8 to get minus 40. Then the two middle terms are like terms, they can be combined. So your final answer would be 2x squared plus 2x minus 40 is your final solution there. So that's the FOIL method, and that's an important skill that will also be on the final exam.
Made with Doodlecast Pro.